Great. Um, Last time in the last session we learned about the median for data type 3, where we saw how to find the item that is found in the middle of a set of data, especially for data type 1. So this time we are done with this all the measures of central tendency as we announced in the previous video, and now we are moving to data type 2. We know we introduced this when we were trying to identify in the video of for identifying data types, and we have made some of the characteristics that is known for to identify something as data type 2. So for the we want to find a logic, right, behind data type 2, how data type 1 connects to data type 2. That's the logic we want to explore today, because if you understand that, we will see that it is easier to handle data when we mostly understand it in the format of data type 2. So we are going to look at through some of the examples. Again, we are just looking at how to make sure that data type 2, right, is understood. If we understand it, I believe that we can easily do all the other operations on them. It's a very important thing because all the other data types mainly focus or connect to what data type 2 does. So it's very important that we pay real attention to what the data type 2 series. Yes, we know that data type 2 appears in this format in a table. This is what we said in the introduction video, where we have the items and against the account. They usually come in a table and they appear in terms of items against counts. So the items are the individual elements, and the element can be anything. We say that they can be anything. They can be name of a place, they can be name of food, they can be anything at all you can think of. But we are going to focus on numerical data type of items. The items are going to be in terms of numbers. So the first item that we have here is item 2. The item number 2 and item number 4, item number 5, 6, 7, 8, 9. These are the items that we have here. So this one could have been name of a place, Accra, Kumasi, or whatever. But because for our scope, right, of learning, we want to focus on numerical data. So the items are going to be numbers mostly. So yeah, so the other two are in terms of they come in a table and they are in the format items against count or frequency. The count we say frequency multiple times. If you have been following us, you see that when we say count, we mean the same as the frequency. It basically means that if you have this set of in the set of data that was grouped in this table, the set of data that was grouped in this table, um, uh, for the item two, you find it only one. So the number of two in the data set is one. That's what the count one for. The item 4, we have found that there are seven of the fours in the data set. So if you count the number of fours in the entire data set, there are 7 of them. If you count number of 5 in the other, there are 6 of them. Like that. So all of the two sides are numbers. So don't confuse them. These ones are items, and then the other ones are the count of those items in the entire data set. So it's very important to get that difference. But they usually come in terms of items against counts. Simple like that. But then how does it connect to data type 1? How does it relate to data type 1? That's the very important thing. Now, why do we even need to do that? So we are going to look at an example to explore the logic behind that. Yes, so this is the example that we have. We have this large data. We know that in this format, as we know, it doesn't come in a table form. So it is definitely our data type 1, like how we explained in the previous videos. And then this is a bit longer, right? The example that we saw for data type 1, we see that they were short, simple, the repeats were small and those stuff. But for data type 1, for data type 2, what happened for this particular data, if you want to use this using the data type 1 approach, it's possible, but it's going to be more difficult. So that's where we need data type 2 to do that. So why do we even need data type 2? Because one, the data is very long, like the data numbers, right? The items are long, so the size is relatively long, and we are seeing a lot of repetitions. A lot of things are being repeated, right? A lot of things are being repeated, a lot of them. So that's why you see that um we need data type 2 for this. The other type 2 will help us handle them in a table. So we are going to look at how this is done. So a lot of items here have been um repeated. So it's not easy to handle it using data type 1. So data type 2 is give us a clearer picture. So let's see how we can do that. So but first I want to list the items. So I want to list the individual items that I can find here. So let me name them as items here. So all the items here. So I can see one, right? One, I can identify one is part of the data set. So that one item I found is item one. I can see two here. Two is part of it. Three is part of it. I can see four. I can see five. I can see six too. Seven. Yeah, I think I can see seven in the data set. Yes, is there eight? Is there eight? Okay, there's no eight inside. There's no nine. There's no 10. I think yes, we are good with that. We are good with that. So the items that we have is 1, 2, 3, 4, 5, 6, 7. Those are the items that we have. Now what we need to do now is we need to now have the account. The count, right? Let's try to get the count. So now let item one. The one, let's start from the edge here and see where we can find one. So there is one here. There is another one here which I circle already. That is 2. There is another one 3. There's another one 4. So here is counts or the frequency. So we said 4 of them. So we are done with one. So two. You have to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 of them here. 10 of the twos. Then let's go to 3. Let's go to 3. Item 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So I have 16 of the 3 here. Then what do we have it? 4, right? Let's ask 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11. Yeah, can we find 11 of the 4? Yeah. Let's go to 5. Item 5, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 of the 5s. Now you go to 6. 6. You have 1 here, 2, 3, 4, 4 here, then 5. Yeah, I have 5 of the 6. And then the last one 7, right? How many 7 do you have? 1 here, you have 2 here, and 3. So we have 3 of the 7s. So 3 of the 7s, right? These are the items that you have finally for this is so this is data type 2. You see that we have transformed the data type 1 to data type 2. The reason being that the items, right, the size of the data set that we have is large, and we are seeing a lot of repetitions of the items. So most of the things are repeated, right? So that's why data type 2 help you to have a clearer picture. You arrange them in a table nicely so that you can use them. Now if you want to find the total number of items here, every item here, what's the number of items that you have there in total? What do you think we should do? So we know the count of 1, the count of 10, right? So to know the total number of items that you have, why don't we just sum up only this guy? So what we need to do is just to sum up these guys, right? To sum up these guys. So it's going to be 4 plus 10, that's 14, right? Plus 16, I think that's 30. That will be 30. 30 plus 11. 30 plus 11, that will be 41. 41 plus 9. This 9, that will be 41 plus 9, that will be 50. 50 plus 5, that's 55. 55 plus 3 is 58. So the total number is 58. So all the items here, they are 58. That's huge, right? For the type 1, we're just managing something like all of them are 10 or 11. That's good, but this is great, like 58 items. If you count all of them, you see 58 items. Yeah. So the total frequency, right? The sum of all the frequencies. So usually we represent frequency by f. So the sum of all the frequency, just with the sum of all counts, give you the sum of the number of items in all, in everything. So we learn that this one means like the sum of f. So the sum of f is 58. Yeah, we'll explore this in the next session. So you see this one is called sigma. Sigma f is just like the sum of all frequencies, the sum of all counts, the sum of all repeats is 58. That gives you the number of individual items that you have. That is how data type 2 comes about. That's the logic behind data type 2, right? Data type 1, the number of elements is relatively huge, and there is a lot of repetition, a lot of items repeat. So it's just useless to be rearranging them and be doing those mean and things on them. So a better way of seeing it, or a better way of using this data, is by putting them nicely in the table. That's when data type 2 helps you. So this data type 1 that you arrange nicely in the table, that's what we recognize as data type 2, right? So from now, we are going to do the mean, mode, median on data type 2. So first, you need to understand the logic behind data type 2, which is the reason why we try to take our time to explain to you. Yeah, so when you see in the field, we dealing with items, we're dealing with data that is already arranged for us. It will be already arranged for us in this data type, but it's good for you to know how wide we didn't use the data type 1, right? So data type 1 is possible to use it, but then data type 2 helps you to get data type 2 help you to handle data type 1 that is having a lot of repetitions, and all the items are mainly like 30, 40, 50 items in all. Here we have 58 items in all, right? It's large and it's a lot of repetition. That's why we see some of them are 4, some of them are 10, some of them are 16. Only one thing is 16. Like, yes, so it's better to use data type 2. That's how data type 2 came about, and then we are going to use data type 2 to find a mean, mode, median, and then see how do we go about that. Thank you, and I hope to see you in the next video.